Hello everyone, this is Dr. Rajesh and I am again with you with my next video lecture, and this video lecture is on the concept of finding velocity at any point of the trajectory. So we have to find the velocity at any point of the trajectory. Trajectory means the path of the projectile, the path that projectile follows, and we have to find the velocity at any particular point of it. So let me first draw the figure and take this figure. In this figure, if we see, this O is the origin and this U is the velocity of projection, initial velocity, and this projectile is projected through this path with angle of projection alpha. So if I say that the components of this velocity u are given by this component will be u cos alpha, and this component will be u sin alpha. So, and we know that in case of projectile, this horizontal component of the velocity always remains the same. Now you look at here, at this point P, velocity has this much direction, and this is the velocity V. V is the velocity at any point of the trajectory. So if I say this is making an angle with the horizontal line, so if I resolve this velocity into two components, its horizontal component will be given by V cos theta, and the vertical component V sin theta. So this will be in this direction and this will be in this direction. So before proceeding further, we have studied during the motion of the projectile two important formulae, and that I am again going to write. U cos alpha t is equal to x coordinate and y is equal to u sin alpha t, and you may name it as equation number 1, you name it as equation number 2. These are the coordinates of any point on the trajectory, so that we have derived earlier. In this case, we know that this u cos alpha t, that u cos alpha, this component of the velocity, we have studied, always remains the constant during the motion. The horizontal component of the velocity always remains the constant, so as that its horizontal acceleration will become zero, and so that the body is under the influence of only force of gravity. So this horizontal component, we have to take it in consideration, will always remain the same. So if we have resolved the velocity into two components at point P, the first component is V cos theta, which will be same because horizontal component at every point of the velocity will remain the same. So this V cos theta will be equal to U cos alpha, and V sin theta will be equal to, we know that a important relation, that V is equal to U plus Ft, where V is the velocity at any time t. So this is the that case, that this is the velocity at any time t. So and when we are talking about the vertical component of the velocity, so this is the final vertical velocity, this is initial vertical velocity. So final vertical velocity at point P, it will be this V sin theta. So if I write this V sin theta, and initial vertical velocity is u sin alpha, so it will be u sin alpha, and since the motion is against the gravity, so this will be, acceleration is minus g t. Fine, you may name it as equation number 3 and you may name it as equation number 4. So now we have to find the, look at the uh, article velocity at any point of the trajectory. When we talk about the velocity, we need to determine two things. Velocity is a vector quantity, we need to determine its direction, and when we talk about the direction, we need to determine theta, and we need to determine its magnitude. So as to determine theta, what we are going to do, we are going to divide divide 4 by 3, we get v sine theta upon v cos theta is equal to u sine alpha minus gt upon u cos alpha. V to v will cancel out. This implies that tan theta is equal to u sine alpha minus gt upon u cos alpha. This implies that theta is equal to tan inverse u sin alpha minus gt upon u cos alpha. So here we have determined the direction of the velocity at any point P. So this direction is known now, and it is known by equation number, I may say, equation number 5. Now we need to determine its magnitude. So can we do one thing? We will square 3 and 4, then add. Then let us see what we get. We are going to squaring and adding equation number 3, squaring and adding equation 3 and 4 and 4, we get it will be v square cos square theta v square sin square theta is equal to u square cos square alpha plus u sin alpha minus gt. So this implies that it will be v square, and inside we are left with cos square theta plus sin square theta. This is equal to u square cos square alpha plus u square sin square alpha plus g square t square minus 2 u sin alpha. This is gt. So we know cos square theta plus sin square theta is 1. So this implies that v square is equal to this one, and so is the case with u square, because sin square alpha plus cos square alpha is again 1. So this will be u square, and then we can write g square t square minus 2u sin alpha gt. So next is u square. I have taken minus 2g common from these two terms. I have taken minus 2g common. So this will be g square t square minus 2g. It will be plus u sin alpha t. Fine. Here g to g will cancel out. This will be u square minus 2g. This will be u sin alpha t minus gt square by 2, because this here is minus, so here is minus gt square by 2, gt square by 2. Now we go back to equation number 2. What is equation number 2? From equation number 2, this thing is equal to y. So I'm going to use this equation number 2. So, and right here this will be u square minus 2g y, and simply mention by using 2, by using 2. This implies that we have calculated velocity square at any point p is equal to 2gy. This implies that velocity is equal to u square minus 2gy square root. Fine. So you may name it as equation number 6. So equation 5 and 6 gives complete information about the velocity at any point p of the trajectory. Next we will move towards an important result concerning this particular formulae, and the result is given by, that result is important from the examination point of view also, and the result is given by this one. To show that magnitude of velocity at any point of the path of a projectile is the same as would be acquired by a particle in falling freely a vertical distance from the level of directrix to that point. So to just understand this particular problem, we will draw a figure, and the figure is given by this one. Look at here. This is P any point on the trajectory of the projectile, and this is the directrix of the projectile. Now we see velocity at this particular point is given by equation number 6. So we can write that velocity at this particular point will be given by this expression. Also, we know that the equation of directrix, we have derived it, is given by u square by 2g. So this we have derived. So what can we do? One thing, we can take 2g common from here. What it will make? It will make u square by 2g minus y, and here is the square root. So if this point is P, so can I name this particular point as Q and this particular point as a R? So if I say that 2g u square by 2g is this particular ordinate from here to here, this distance, this vertical distance from here to here is u square by 2g. So if I say that this is QR, because equation of directrix is y square is equal to u square by 2g. So can I place it? Y is the ordinate, the height directrix has. So this can be written as QR distance. So I'm going to write it here as QR minus y. Y is the ordinate, means the height of point P, and this height is this much. So can I write here as PR and closing the braces and just take the square root? This thing will be further equal to 2g QR, this QR, this whole thing minus this PR will be QP. Okay, so this will be QP and the square root. So this will be the velocity at any point P. Now that is the velocity of the projectile at any point P. Now we will see that what velocity it will acquire when it is allowed to fall freely, when it is allowed to fall freely from here, and when it will fall, its initial velocity will be 0, and when it will reach here, its velocity will be v. So let me calculate. We know the relation v square minus u square is equal to 2 fs. Now look here, we calculate the initial velocity is 0. So this will be v square minus 0 square, and since it is falling in the downward direction, so it is falling in the direction of force of gravity. So if I say that this g will be positive, this will be 2g, and height it will fall, from Q to P. We have to find the velocity that it will acquire when it is allowed to fall freely from here. So reaching at this particular point, it will travel the distance QP. So may I write it as QP? So this is the velocity. Okay, and if I say that this is further equal to V is equal to 2g QP, and if I name it as equation number 7 and equation number 8. So from equation number 7 and 8, it is clear that we have proved that the magnitude of velocity at any point of the path of a projectile is same. Magnitude of velocity at any point of the path of the projectile is given by 7, is same as would be acquired by a particle in falling freely a vertical distance from the level of directrix to that point, means from here to here, falling freely. So velocity acquired in falling freely from the height of directrix to that particular point is given by question number 8. So from 7 and 8 both are equal, hence we have proved the result. This result is very important from the examination point of view. So in this we have discussed the concept of velocity at any point of the trajectory, and I hope that I am able to make this concept clear in your minds. So that is all I have from this lecture, and if you have liked the lecture, please like, subscribe, share and comment. And always remember that your comments in the comment section are always valued, and I appreciate them very much, and I always wait for your comments, and you may raise your query if any in the comment section also. So this is all I have from this lecture. This is Dr. Rajesh saying you goodbye. Take care. Bye bye.